Hey guys, today we're going to talk about the notes for 6.4. So the title is Graphing Linear Inequalities. So by the end of today, you should know how to graph a linear inequality. Okay, so just some things to remember. Okay, if the symbol's less than, it will be a dotted line, and the shading will be below the line. If the symbol's less than or equal to, it'll be a solid line. Make sure these are lines, and the shading will be below the line. If the symbol is greater than, it'll be a dotted line, and the shading will be above. And if it is greater than or equal to, it will be a solid line, and the shading also will be above. Okay, so we want to be able to graph an inequality. Okay, and so just remember kind of the progression of what we've done. We've graphed lines, okay, or linear equations. We've solved linear equations, and then we've applied it with word problems, okay? So that's kind of the progression here. So our first step is to be able to graph a linear inequality, okay? So the good news is you know how to do a lot of this, okay? So let's jump into this first example. It says sketch the graph of the following linear inequality. So I'll read this. Y is greater than negative 2x plus 6. So notice that it is in y equals mx plus b form. Okay, so we're going to graph this just like we would a normal line. Okay, we're going to start with the y-intercept. All right, y-intercept is 0, 6. So I'm going to put a point on the y-intercept, okay? Then we're going to use the slope next. So my slope is negative 2, which is negative 2 over 1, okay? So I'm going to use that slope, all right? Now when I count slope, remember I count up and right if it's positive, and I count up and left if it's negative. So I'm going to go up 2, and it's left because it's negative, okay? Now, the difference here is we don't just connect the dots with a solid line. We've got to look at the inequality. The inequality is greater than. Okay, inequality is greater than. So what we need to do is determine, is it solid or is it dotted? Well, greater than only, it is a dotted line. So we're going to connect these two dots with a dotted or a dashed line. You'll hear me say dashed line sometimes in class, okay? So if we're graphing just a regular line, then that would be it. But since it's an inequality, it's not just a line, it's an interval, okay? So we need to determine where y is greater than that line. Well, remember our kind of key up here. If it's greater than, we're going to shade above. So above the line here would be this area, all above the line. So that's how I kind of do my shading. You can get fancy and you can color it in all you want, okay? But for now, that's what it's going to look like, all right? Now, what we want to do is we want to kind of test this, okay? We want to test it and see if it works, all right? So we want to pick a point that is in the shaded part, any point you want. So I'm just going to pick a point. So let's see, I'm going to pick this point right here. It's in the shaded part. So that is 1, 2, 1, 2, 3, 4, 5, 6. So I'm going to test the point to 6. Okay, and how we test this point is we plug it in to our equation. Okay, x is 2, y is 6. And see if we get a true statement. So I'm going to see if 6 is, in fact, greater than. I'm going to put question mark here because we don't know. We're just testing it. Okay, so then I'm just going to simplify it. So negative 2 times 2 is negative 4. And then negative 4 plus 6 is a positive 2. So 6 is, in fact, greater than 2. So we shaded in the correct direction. Okay, that's what that looks like. All right, let's look at number 2. So notice on number 2 that it is in standard form. So in order to graph it, we want it to be in slope-intercept form, or y equals mx plus b. So we've got to do a little bit of algebra and move some stuff around. So I'm going to move my 3x. I get negative 2y is greater than negative 3x plus 8. I'm going to divide everything by negative 2. It's an inequality. I divided by negative 2. Something in your head should say, whoop, whoop. We're going to have to flip that inequality. So y is less than positive 3 halves x minus 4. Okay. So I want to graph that. So I'm going to start with my y-intercept, 0, negative 4. Graph that point. Has a slope of 3 over 2. So I'm going to move up 3, right 2. I'm going to ask myself, is it a dotted line or is it a solid line? So it's less than, so it is a dotted line. So I'm going to connect my points with a dotted line or dashed line. And since it is less than, I'm going to shade below the line. Okay, I'm going to shade below the line. All right, so let's test a point. All right, I want to test a point. So I'm going to pick a point inside the shaded region. So I'm going to pick this point right here. I kind of like this point because the point is 4, 0. Point's 4, 0. All right, 0 is always easy to deal with. So x is 4, y is 0. And I'm going to plug it into my original. So I've got 3 times 4 minus 2 times 0. I want to see if that's greater than 8. So 3 times 4 is 12. 12 minus 2 times 0 is 0. 12 minus 0 is 12. And I would say, in fact, 12 is greater than 8. Therefore, we did graph it correctly. Okay. All right. What I want you to do now is I want you to pause the video and try number 3. Pause the video and try number 3. All right, on mine, these are not showing up, so I'm going to put what these are supposed to be. This is supposed to be 3x minus 3y. Is that greater than or equal to negative 6? So go ahead and hit pause, and then try number 3, and then when you get done, hit play, and then you can check your answers. All right, let's see how you guys did. So first, we've got to put it in y equals mx plus b form. Okay, so I need to move this 2x over. Negative 3y is greater than or equal to negative 2x minus 6. Divide everything by negative 3. Y is greater than or equal to, oh, I messed up because I forgot to switch it. Whoop, whoop. Should have said that. Switch it to less than or equal to positive 2/3 x plus 2. Okay, so that's the correct line we need to graph. So has a y-intercept 0, 2. I'm going to start there. Has a slope of positive 2 over 3. So I'm going to move up 2, right 3. It is less than or equal to, so that means it is a solid line. So we do want to draw a solid line. And since it is less than, it is below the line. Okay, now I do want to test a point. I want to test a point here. So I love picking the point 0, 0 when possible. 0, 0 is in my shaded part, so I'm going to pick the point 0, 0. So I'm going to plug in 0, 0. And I want to see if that is greater than or equal to negative 6. 2 times 0, 0. 3 times 0, 0. 0 minus 0 is 0. And 0 is, in fact, greater than negative 6. Therefore, we did it right. Okay. All right, I'm going to look at the last one. Okay, last one on our notes. So first I need to fix it. X is greater than or equal to 3. X is greater than or equal to 3. All right. So we've got to remember when we have X is equal to a number, what kind of line it is. Y is equal to a number, what kind of line it is. All right. So I'm just going to write over here, when Y equals a number, it's a horizontal line. And what number, that number tells us where the line crosses the y-axis, horizontal, left and right. When X equals a number, it's a vertical line. And that tells us where the line crosses the x-axis, okay? So let's look at this one. It's X equals a number. X is greater than or equal to a number. It's a vertical line. All right, so when you see that, you should think, all right, this is a vertical line, up and down. Okay, so I'm going to go to where it crosses the x-axis, and it gives me the point that it crosses the x-axis at, and it's negative. Hopefully these symbols showed up on yours. That is a negative 3. Okay, so negative 3 is where it crosses the x-axis. And it's a vertical line. So before you draw your line, you again, since it's an inequality, you ask yourself, is it a solid or is it a dotted line? Well, it's a solid line. So I'm going to draw my solid vertical line. It's a pretty good line, free-handed, no ruler. Okay, now shading. Shading, greater than. So it's not above or below. It's left or right. Okay, so when is it greater than? Well, to the right of this line is where it is greater than. Okay, so I'll do, and you can test one here, test point. So again, I want to choose 0, 0. 0, 0 is a test point. X is 0, Y is 0. Well, there's no Y here, so is 0 greater than or equal to negative 3 is all I'm looking at. Yes, it is. So we did it right. Okay, all right. So hopefully now you feel like you can graph a linear inequality. Okay, do your assignment. Hopefully you have success. Make sure you check your answers, and